Hello student, welcome to my channel Learn Physics. Today I will be discussing the exemplar numerical MCQ and short question of gravitation. This is the chapter 10 of class 9 science. Now I have already uploaded the one short video of theory and numerical of all chapters of class 9. To boost up your content, you can watch these videos. I will give a link in the description box. Now let's start. Two objects of different masses two objects of different masses falling freely near the surface of moon would have same velocity at any instant. Look at this velocity at any instant v equal to acceleration due to gravity at moon g dash into time of fall. So velocity of all object in a given time interval is gt dash is g dash t is always constant. So option A is correct. Okay. Now question number 2. The value of acceleration due to gravity is same on equator and poles. You know the polar radius is less than the equatorial radius. Okay. Therefore, acceleration due to gravity at pole is greater than acceleration due to gravity at equator. Now, option B is least on poles. No. Is least on equator. Okay, C option is correct. Now, question number 3. The gravitational force between two objects is F. Now, F equals to, this is the G, M1, M2 divided by R square is the gravitational force of attraction between two objects M1 and M2. If the masses of both the objects are halved, that is m1 becomes m1 by 2 and m2 becomes, look at this m2 becomes m2 by 2 without changing the distance between them, that is r is constant. Okay, then the gravitational force would becomes, look at this, m1 becomes m1 by 2, m2 becomes m2 by 2, so half into half, this is the 1 by 4, so gravitational force becomes 1/4 of initial force F. Okay, so this becomes F by 4. Option A is correct. Okay, now question number 4. A boy is whirling stone tied with a string in an horizontal circular path. If the string breaks, the stone will continue to move in the circular path. No. Will move along the straight line towards the center of the circular path. No. Will move along the straight line tangential to the circular path. Look at this. For a circular motion of an object, at the direction of motion is always directed tangentially. So option C is correct. Will move along a straight line tangent to the circular path. Okay. Now question 5. An object is put one by one in three liquids having same different densities. The object floats with 1 by 9, 2 by 11 and 3 by 7 part of their volume outside the liquid. Mind it, this is the outside the liquid. Now we concentrate the portion inside the liquid. Okay, the density of liquid d1, d2, d3. We have to establish the relation between d1, d2, d3. Okay, now look at this. The weight of the object, sorry, the density of the object capital D is the volume of immersed part, that is 1 minus 1 by 9 into density of the liquid. So this is the 8 by 9 d1, understood? So from here d1 is equal to, so from here d1 equal to, this is the 9 by 8d, understood? In the same way, for second liquid capital D equals to 1 minus, this is the 2 by 11, very important relation it is. d2. Therefore, this is the 9 by 11 d2. Okay. So from here, d2 equal to, this is the 11 by 9 d2. So from, look at this, from observation, d2 greater than d1. Now for third liquid, capital D equal to 1 minus, this is the 3 by 7 volume of immersed part into density of the liquid d3. So look at this is the 4 by 7 d3. Okay, understood? Now d3 equal to, look at this is the 7 by 4 into capital D. Understood? So look at this is greater than this and this greater than this. Therefore, D3 greater than D2 greater than D1. Okay. Now, option is D. D1 less than D2 less than D. Okay. Understood? Next. Now, question number 6. If the relation capital F is capital G, capital M, small m by d square, the quantity G, universal gravitational constant. So it is universal constant of nature. Now question number 7. Law of gravitation gives the gravitational force between the earth and a point mass. No. The law of gravitation the law of gravitation is applicable for any two bodies having some mass. Now question 8. The value of quantity capital G in the law of gravitation is independent of mass of radius and earth. Okay, it is independent of mass and radius of the earth. It is universal in nature. Okay. Now question number 9. Two particles are placed at some distance. If the mass of each of two particles is doubled, keeping the distance between them unchanged, the value of gravitational force between them. Look at this, the gravitational force F, this is the capital G, M1, M2 whole divided by D square. Okay. Now look at this, M1 and M2 both are 2 times. So 2 times into 2 times, that is the 4 times. So gravitational force becomes 4 times of initial gravitational force. Now question number 10. The atmosphere is held to the earth by gravity. Okay. Now question number 11. The force of attraction between two unit point masses separated by unit distance is called universal gravitational constant, because the universal gravitational constant G equals to F if the mass of two objects be 1 and the distance of separation also be 1. Okay. So look at this. This is the universal gravitational constant, is the force of attraction between two unit masses separated by unit distance. Now question number 12. The weight of an object at the center of the earth of radius r is, look at this, the acceleration due to gravity at the center is 0. So obviously weight of an object at the center is 0. Okay. Now question number 13. An object weighs 10 Newton in air. When immersed fully in water, it weighs only 8 Newton. The weight of the liquid displaced by the object will be, look at this, the weight of the liquid displaced by object is the upthrust. Now the force of upthrust is the weight in air minus weight in water. So this is the 10 Newton minus 8 Newton. So this is the 2 Newton. Now question number 14. A girl stand on a box having 60 centimeter length, 40 centimeter breadth, 20 centimeter width in 3 hours. In which of the following cases pressure exerted by the brick will be, look at this, the pressure P is inversely proportional to the area of contact. Now look at this, the maximum when length and breadth forms base. Look at this is the length and this is the breadth. So area is the this into this. So this is the 2400 cm square. Okay, this is the maximum. This is the maximum area. So the pressure is least. So this is incorrect. The maximum when breadth and width forms the base. Look at this. 40 centimeter into 20 centimeter is the minimum area. So pressure becomes maximum in this case. Now question number 15. An apple falls from the tree because of gravitational attraction between the earth and apple. If F1 is the magnitude of force exerted by the earth on the apple and F2 is the magnitude of force exerted by apple on earth, then F1 equal to F2 because gravitational force of attraction are equal and opposite in nature because they are action reaction force. Now short answer type question. Now, short answer type question 16. What is the source of centripetal force that planet requires to revolve around the sun? The gravitational force of the gravitational force of attraction between between sun and planet provide necessary centripetal force for the motion of the planet around the sun. Okay, on what factors does the force depends on? This force depends on mass of the sun, mass of the planet, and distance of the planet from the sun. Now, question number 17. On the earth, a stone is thrown from the height in a direction parallel to the earth surface. Okay, now this is the parallel to the earth surface, while another stone dropped simultaneously from the same height. Now, another stone drops simultaneously from the same height. That is initial velocity equal to 0. Now the first object which is given a initial horizontal velocity, its vertical velocity also 0. So both have initial vertical velocity 0. So they take same time to reach the ground. So they take same time t equals to root under 2h by g to reach the ground. Only differ, one falls at the base and other falls some distance from the point of projection. Now 18. Suppose the gravity of Earth suddenly becomes 0. Then in which direction the moon begins to move, or if no other celestial body affects it? Look at this. The, the moon revolves around the earth in a circular orbit and its velocity always directed tangentially. If centripetal force, that is gravitational force on moon vanishes, the moon moves tangential to its path. Okay. Now question number 19. Identical packets are dropped from two aeroplanes, one above the equator and other above the North Pole, both at height age. Assuming all conditions are identical, will those packets reach will will those packets take same time to reach the surface? No. Because look at this, the time of fall t is inversely proportional to 1 by root under g. You know the g at pole is greater than g at equator. As, as g at pole is greater, so time of fall at the pole is less than the time of fall from the equator. Now question 20. The weight of any person on the moon is 1 by 6 times that of the earth. He can lift the mass 15 kg on the earth. So weight lift by person on the earth is 15 into acceleration due to gravity, that is 9.8 Newton. Okay, so he can lift the weight on moon. So mass that he can lift on the moon, this is the m. So m into this is the 9.8 by 6. So look at this here, m equals to 6 into 15, that is 90 kg. So mass lifted by the person on the moon, this is the 90 kg. Okay, understood? Now question number 21. Calculate the average density of the earth in terms of small g, capital G, and capital R. Okay. Now we know G equal to capital G, capital M divided by R square. That is, acceleration due to gravity is the product of the universal gravitational constant, mass of the earth, and divided by square of the radius of the earth. Now we know the mass of the earth is the volume into density. Volume equals to 4/3 pi capital R cube into rho. If we put the value of m in this equation, we get, look at this, G equal to, this is the G into 4 by 3 pi capital R cube rho divided by, this is the R square. Okay, now this and this equal to capital R. Therefore, look at this. This is the 3g divided by 4 pi r 0. Okay. Therefore, rho equals to, this is the 3g divided by 4 pi r g is the expression of, this is the expression of average density of earth in terms of small g, capital G, and capital R. Okay, understood? The earth is acted upon by the gravitation of sun, even though it does not fall into the sun. Why? Look at this. Suppose this is the circular orbit on which the earth revolves around the sun. This is the position of the sun, and certain part, suppose a particular instant, the velocity of the earth is directed tangent to its path. Okay. Now this is the velocity. The due to this velocity, the earth experiences an outward centrifugal force. This is the mv square by r. This mv square by r is balanced by attractive gravitation force on earth due to sun. Due to these two forces are balance each other, that is why earth does not fall on the earth. Okay, understood? Many thanks for watching this video. This video will be extremely helpful for you to get the good marks in your examination. I assure you this video helps you to build your concept properly. Please like, share, comment on this, and to learn physics easily and quickly, subscribe my channel. Okay, thank you.